Hello students, in this class we'll study refraction by a lens where we are deriving a lens maker's formula. We are deriving the lens maker's formula. Why it is called as lens maker's formula? Because this equation is used to design the lenses of desired focal length. If you want to have a lens of focal length 10 centimeter, then using this equation we can have the lens of 10 centimeter focal length. So you can get a lens of a desired focal length. That is what this formula is called as lens formula. By looking at the equation at the end, you will come to know how this equation is used to manufacture the lenses. Now, let us consider a lens of refractive index N2. Let us consider a lens of refractive index N2. It is kept in a rarer medium of refractive index N1. Let O be the point object on the principal axis kept in a rarer medium. And after refraction through the lens, finally the image I is going to be formed in the rarer medium. So image formation in this um, image formation can be studied in two steps, because refraction is taking place at two surfaces of lens. First refraction takes place at first spherical surface, then again refraction is going to take place at second refracting surface. So image formation, the image I formation is studied in two steps. Now this equation is derived using a convex lens, but it holds good for concave lens also, and this is a 5 marks question. Now we'll see how the image formation takes place. The first refracting surface, we are taking a first refracting surface A, B, C. We are taking the first refracting surface A, B, C. The incident ray from the object O strikes the first surface and it refracts into the denser medium of refractive index N2. Now, to measure the angle of incidence and angle of refraction, we require the normal to the point of incidence. How to draw the normal? It should be perpendicular to that point. And the spherical surface is a part of a sphere. Then a line joining from that point to the center of curvature gives you the normal to the surface, because that is the radius of the spherical surface and that will be always perpendicular to the point. So we are measuring the angle of incidence I and angle of refraction R1, and this is our center of curvature of first refracting surface C1. So first refracting surface forms the image I dash of the object O. To this refraction at first surface, we have to apply the equation that connects object distance, image distance and radius of curvature. And this we are applying for the first refracting surface ABC. Now what is that equation? In the previous class we have studied refraction through the spherical surface. Refraction through the spherical surface we have studied. In that we have got an equation. By substituting in the Snell's law I and R, we have got the equation. See, what is the equation? N1 divided by MO. What is N1? It is the refractive index of the medium where object is placed, divided by object distance, plus N2, refractive index of the medium where image is formed, divided by image distance, equal to N2 minus N1, the difference between the refractive indices of the two medium, divided by the radius of curvature of that refracting surface. So the same equation we are applying for both the refracting surfaces of a lens. What is the equation? Refractive index of the medium where object is there divided by object distance plus Ri of the medium where image is formed divided by image distance. Okay, so here in the first refracting surface where the object is in the rarer medium n1, so n1 divided by object distance bo plus the refractive index where the image is formed in the denser medium n2 divided by the image distance. So let this refracted ray is going to form the image at I dash I1. So BI1 is the image distance is equal to N2 minus N1, the difference between the two refractive indices divided by the radius of curvature of that refracting surface. BC is the refracting surface. Now, after writing the equation, we have to apply the sign convention. How the sign convention is? The distances should be measured from the pole, from the B you have to measure. Then if the distances are measured opposite to the incident direction, they are taken negative. So your incident direction is towards right, you are measuring BO towards left, so BO will be negative. BI is in the direction of the incident ray, it is positive BI dash, as well as BC1 is also measured in the direction of the incident ray. So BC1 is taken as positive. See, N1 minus U plus N2 BI dash is equal to N2 minus N1 plus R1. Let us denote this as equation 1. Now, the image formed by first refracting surface acts as the virtual object for the second, or you can say, see, here is the first refracting surface. So this is the incident ray which is emerging from the object O. When it strikes the first surface, it get refracted. And the refracted ray from the first surface acts as the incident ray for the second surface. Refracted ray from the first surface acts as the incident ray for the second surface. So this refracted ray is corresponding to the point I dash. So this ray corresponding to the point I dash, so I dash is taken as the object. Or in a simple way you can consider, instead of after refracting from the first surface, if the second surface is here, assume the second refracting surface is here, then how would I have got the incident ray? From I dash to the second surface. So this is the incident ray. After refraction, somewhere here you are going to get the final image I. How do you measure the object distance? From the pole of the second refracting surface, that is nothing but D to the object I dash. So DI dash will be your object distance for the second refracting surface, and the rays emerging from I dash will be the incident ray for the second refracting surface. So in accordance with that, I dash will be the object for the second refracting surface. Why? I dash is corresponding to the incident ray on the second surface. How it has become incident? After refracting through the second surface. So I dash is the virtual object. Actually it has not formed. Before forming, only the incident ray falls on the second refracting surface and the image I is formed by the second surface. So I dash is a virtual object for the second surface. Now again, similar equation can be applied at second surface, which connects object distance, image distance and radius of curvature. So how to write? Ri of the medium where object is there divided by object distance plus Ri of the medium where image is formed divided by image distance is equal to difference between the refractive indices divided by the radius of curvature of the refracting surface, curved refracting surface. So object is there in the denser medium. Object, because the incident ray is in the denser medium. So you have to consider object is there in the denser medium. So Ri of the denser medium is N2 divided by where the image would have been formed, I dash, which acts as the object for second surface. So di dash is the object distance for second surface plus the Ri of the medium where image is formed, final image in rarer medium, N1 divided by di is the image distance is equal to N2 minus N1 divided by the radius of curvature of the second curved surface. So this is the second curved surface. Here is our radius of curvature of the second surface. DC2, apply the sign convention. DC2, so is taken negative because this is our incident ray on the second refracting surface. We are measuring the radius of curvature opposite to that because always the distances are measured from the pole of the refracting surface. So D is the pole of the second refracting surface. We are measuring from D to C2, that is in the opposite direction of the incident ray. So DC2 is taken negative. N1 divided by DI. DI we are measuring image distance from the D to I we are measuring, which is in the direction of the incident ray, that is taken positive. Now the object distance DI dash. You may ask, in the diagram DI dash is in front of the lens, and why we are taking it as a negative. So as already I have told you, if the second surface is here, the rays from the I1 would have traveled to the second surface and then refraction would have taken place. So di dash we are measuring opposite to the incident ray because the I dash is in the denser medium. I dash is in the denser medium. The incident ray is traveling towards the rarer medium. So I dash, di dash has to be taken negative. See, the ray is traveling towards the rarer medium and the image di dash would have formed in the denser medium. So di dash is taken as negative. So minus N2 divided by di dash. Now what will this will denote as equation 2. Now what we'll do, we'll add equation 1 and 2. Equation 1 and 2 will be added, and for a thin lens, so this is our first refracting surface B, second refracting surface D. So in practice this lens is not this wide, it is very thin. So this is B, this is D, and somewhere here the image I dash is formed. Somewhere here the image I dash is formed. So look at the distances. I dash is almost equal to D I dash. B I dash is almost equal to D I dash. So both are taken same. B I dash will be equal to D I dash. So here in place of D I dash we can substitute B I dash. We can substitute B I dash. So that when you add equation 1 and 2, N2 by B I dash and minus N2 by B I dash. It is D I dash, but as we are equating it with B, both will get cancelled. What remains is N1 by minus U and N1 by V plus N1 by V on LHS. On RHS, it is N2 by N1 by R1 minus N2 by N1 divided by minus R2. So if you take n2 by n1 common from both the equations, you are going to get 1 upon r1 minus 1 upon r2 in the right hand side. Now let us denote this equation as equation 3. Now, suppose the object is placed at infinity. So what is u actually? Object, this is our u, and this is the final image v. Suppose the object is placed at infinity. At infinity means the rays will be parallel, and where the image is going to be formed? At focal length, principal focus. So your image distance will be focal length f. So if the object is placed at infinity, image will be formed at f. So by substituting object distance infinity, n1 upon infinity will be equal to 0. Now plus n1 by f. n1 by f is equal to n2 minus n1, 1 upon r1 minus 1 upon r2. Now this equation will denote as 3a. We'll denote this equation as 3a. Now what we'll do? We'll take n1 common from this equation, n1 common from this bracket, so that it will become n2 by n1 minus 1 after taking n1 common. Now this n1 and n1 get cancels. 1 upon f is equal to n2 by n1 minus 1 into bracket 1 upon r1 minus 1 upon r2. So n2 by n1 can be written as n21. That is refractive index of the second medium with respect to first medium. So this gives the lens maker's formula. See here, look at this equation. So with the known value of n2, known value of refractive index of the material of glass and refractive index of the surrounding medium, usually it is taken the air only. If you want certain value of focal length, then accordingly the R1 and R2 will be selected. So with the known value of R1 and R2, you can design a focal length or a lens of a desired focal length. Now in this equation 3 and 3a, in both this equation, look at the right hand sides of both the equation. They are same. Right hand sides of both the equation 3 and 3a are same, so you can equate the LHS of both the equation. So that will be n1 by v minus n1 by u is equal to n1 by f. If you take n1 common from the equation throughout, if you take n1, it get cancels, and you are going to get 1 upon v is minus 1 upon u is equal to 1 upon f. This is the thin lens formula. This is the thin lens formula. So you have studied the magnification in case of mirror. What is the magnification? It gives you an idea to what extent the image is enlarged or diminished compared to the object size. So magnification gives you the idea what has happened with the image size. So magnification produced by a lens is defined as, mathematically how to find the magnification? It is the ratio of the size of the image to that of the object. Size of the image h dash divided by h. It can also be equated to v by u. So we'll just revise the equations that you have studied in case of mirror and lens. For mirror, the mirror equation was 1 upon v plus 1 upon u is equal to 1 upon f. In case of lens, it is a thin lens formula where the minus sign is there. So for thin lens formula, 1 upon v minus 1 upon u is equal to 1 upon f. The magnification for mirror is minus v by u, whereas for lens it is plus v by u. So go through the derivation and ask your doubts in a doubt clarification session.